Everyone. Today we're looking at section 6.2, and we're continuing with our rational expressions. And today we're going to be starting to do some operations on them. We're going to be doing multiplying and dividing today. Okay, so let's just get started on this constructor understanding and do a couple of these examples. So I'm going to be doing this two that I've circled here. I'll do the first one here and then the second one down here. So I'm going to rewrite it here so we can see it a little bit better. Okay, and from the Get Ready assignment, we reviewed the fact that we always want to, when we're adding or when we're multiplying fractions, we always want to cancel out any common factors in the numerator and denominator first before we multiply the two fractions together. So that same strategy stays consistent when we have polynomials in our numerator and denominator. We still want to use that strategy. We still want to cancel out any common factors in the numerator and denominator first before we multiply our fractions together. So anything that's in common, any common factors in the two numerator terms, the two yellow terms, compared with the two denominator terms, can be canceled out. So the first thing that I see that's the same right away that can be canceled out is the x plus 1 that shows up in both the numerator and denominator. So I can divide by x plus 1 at 1. Okay. And let's look at those numbers now. -8 and -2, those can both be divided by -2. So when I divide -2 by -2, I get 1. And -8 divided by -2, I get 4. Now this x here, there is no x in the numerator, and so I can't cancel that with anything. So it's still left there. So I still have that x. So this simply changes to the first fraction, everything got canceled, so it's just 1 over 1. And then the second fraction would be 1 in the numerator, and then I have 4x remaining in the denominator. So it's always nice, especially because canceling kind of makes a little bit of a mess of things. It's nice to kind of rewrite what you've got left over after you've done all your canceling. And now we can do our multiplication. So when we're multiplying rational numbers or any fractions together, you just multiply the numerators. So 1 times 1 would be 1. And then you multiply the denominators. 1 times 4x would be 4x. And we've got a nice simple expression there. The reason you want to cancel first is because it saves a lot of headache and a lot of work if you do that. If you don't cancel first, then you do a lot of work for no reason, and you end up having to do a lot of simplifying at the end. Okay, so let's try a dividing question. Recall that when you divide, it's the same as multiplying, but we need to do the multiply by the opposite number, and we call this the reciprocal. So we write the reciprocal of the second fraction. So we keep the first fraction the same, x plus 2 over 5x, and then we multiply it by the reciprocal, so we flip it, the second fraction. Sometimes people call this rule keep, change, flip. You keep the first fraction, change the sign, and then flip the second fraction. Okay, now let's look for our things that we can cancel out. You always want to cancel right before you multiply. So anything that's in common in the numerator and denominator can be canceled out. So let's look at those x plus 2. Those are kind of glaring out to me. Those are in common in the top and bottom. So I can divide them both by x plus 2, and I'll get 1, 1. I also see an x in the denominator and numerator, so I can divide by x, 1 and 1. The 20 and the 2, those can be divided by 2. So anything in the numerator can be canceled with the denominator. So 2 divided by 2 is 1. 20 divided by 2 is 10. And we can actually go further with the 10 because 10 and 5 can both be divided by 5. So this would be 2, and that would be 1. So that's a lot of canceling there. It looks quite complicated, but I basically end up with 1s in the first fraction. And the second fraction, the only thing that's left there in the numerator is a 2, and the denominator was reduced to 1. So it's really simple multiplication to do. At the final step here, it's just 1 times 2 over 1, or that number is simply just 2. Okay, good. So that's the kind of main idea for this whole section. We're just going to be doing sort of harder and harder versions of what I just did there. So let's go ahead to example, check your understanding number 1. I'll be doing both of these because they're slightly different. In the first one, I've got 2 different variables, and the second one, I just have 1 variable. Okay, so I'll be doing both. Okay, so I'm just going to rewrite it. 3b squared over 5a squared. Okay, so canceling first. So I'm going to look for anything that can be, I'm going to use my highlighting a little bit different here. I'm going to highlight things that can be canceled out. So let's look at the numbers first. The 3 and the 9, those can both be divided by 3. So I would get 1 and 3. I have an A. I have 1 A in the numerator and 2 A's multiplied together in the denominator. So I can divide both by A. This would be 1, and this would just be left with A. And then nothing else is in common. There's only B's in the numerator, no B's in the denominator, so I can't cancel those out. Let's rewrite what I've got now after we cancel everything. So in the numerator on the first fraction, I have a 2 left. In the denominator, I've got a 3. In the second fraction here, I've got B squared left and 5A. Okay, so after you do your canceling, I do recommend you rewrite everything just because it's a lot easier to see now. And now I simply just multiply. So 2 times b squared would be 2b squared, and 3 times 5a would be 15a. Now we do have to write any non-permissible values. Pretty much for every single question, actually for all questions in this chapter, you need to write your non-permissible values. And we go back way to the beginning before we did any canceling to look for those. The only variable in the denominator is a. So for this question, it's a cannot be equal to 0. Because if a was 0, we'd be dividing by 0 there. Okay, let's try the second question. 2x squared, I'm just going to rewrite it. X plus 2 over 3x times 5. If you feel confident after looking at that first question, feel free to pause here and try this one on your own. So we want to cancel any common terms in the numerator and denominator. So I'm going to highlight, I'll do the numbers first. I have an 8 here and a 2 here, so I can divide those by 2. So that would become 1 and 4. And let's use a different color now. I have an x plus 2 in the numerator as a factor, and I also have an x plus 2. So anything bracket can be canceled out. So x plus 2 and x plus 2, those can be canceled out. Divide by x plus 2, divide by x plus 2, I'll just get 1 and 1. And I do have x and x. So I actually have 2 x's in the denominator, and I have 2 x's in the numerator. I have an x squared in the numerator. So those can be canceled out altogether. And I think that's it. X minus 4, sorry, shows up only in the numerator, so I can't cancel that. Okay, let's write what I've got left now after all that canceling. So in the first fraction, I just have 1 over 3. Everything else was canceled. And then I have 5 times x minus 4 here, and then I have a 4. Okay, I think that looks fine. So then I would be left with 5x minus 4. You can expand that, but you don't have to. And then over 12. And we have to write our non-permissible values. There's actually 2 of them for this question. We look way back to the beginning, and we see any x's that would make that any of the denominators 0. So we have the first one, x cannot be 0, because we have 3 times x there. And we have x cannot be negative 2, because it would make that x plus 2 factor be 0. Okay, so this is my final answer. All right. Let's go to check your understanding number 2, where we're going to be dividing this time. Dividing is really the same as multiplying. You just have to do the flip first. Okay. Let's do A, and then if you guys want to try B on your own, you can. So 7n cubed over 4, and then we're going to keep change flip. So I'm going to flip this second term, 7n squared. Now for this one, before I can start canceling, I do have to expand this one out because that squared is being applied to the 7 and to the n. So I'm going to just write it out a little bit better here. So it'd be 49n squared. That way we can separate the numbers and the variables. Okay, so now let's look for anything in common that we can divide. Let's look at the numbers first. So I have a 7 and a 49. So I can divide by 7. This would be 1. This would be 7. And I also have 4 and 12. Those can be divided by 4. So this would be 1 and this would be -3. And then I have 3 n's in the numerator and only 2 in the denominator. So I can cancel 2 n's. So these would be completely gone, and this would be left with 1 n. Okay, let's write now what I have after all that canceling. I have n over 1 times -3 over 7. n times -3 would be -3n. Oops. And 1 times 7 is 7. Let's write our non-permissible values. Actually, I've been a little bit lazy and have done these at the end. You should be doing them right at the beginning just because then you can see everything. So you need to look at the first expression with the division symbol. There's actually only numbers in the denominator there, so there's no non-permissible values that would come from that. But from the second expression, from the multiplication expression, I do have an n in the denominator. So we have to write n cannot be 0. Okay. So we look at any time any variable has been in the denominator, whatever would make that variable 0 or that denominator 0, that's a non-permissible value. Okay, pause here. I'd recommend you try B on your own, but I'm going to do it here as well. So we keep, change, flip. We flip that second fraction, write the reciprocal. And we don't cancel until we've flipped it, until we're in the multiplication format. Let's be better and write our non-permissible values now. So let's write them from the beginning up here. The non-permissible values from this expression would be x cannot be 0 and -5. -5 would make this x plus 5 term 0, and 0 would make both denominators 0. But we also need to look at the multiplication expression and add one more non-permissible value, which would be 3. So let's write our non-permissible values here. X cannot be 0, -5, and also 3. So when you're dividing, you have to look at all the different expressions you've written down. Anytime you have a denominator that can be 0, you need to put that as part of your non-permissible value list. Okay, let's do some canceling. We have an x minus 3 in both. We can cancel those out. Divide by x minus 3, I'll get 1 and 1. Let's look at the numbers. I have 5 and 10. Those can be divided by 5. Get 1 and 2. And I also have an x in both the numerator and the denominator. You can cancel those out. We'll get 1 and 1. And I think that's it. Let's write down what we've got left. I have 1 over 2 times 3x plus 5 all over 2. Okay, and then I can write the answer, which would be 3 times x plus 5. 2 times 2 would be 4. There we go. And I've got all of these non-permissible values there. Okay, let's go to the final questions, which are going to be where we actually have to do some factoring. So these ones, the questions were actually factored already for us. In the next example, we're going to have to factor first, and then we can simplify. So I'm going to do check your understanding 3A, and then you guys can try 3B on your own if you want, if you feel like you need more practice. You can also look at these ones here that are done for you as well. So the thing to remember is these ones are factor first. Okay, so let's factor for A. So again, I'm not going to review factoring. If you need more factoring review, let me know. Also, you should have reviewed it a bit in the Get Ready assignment. For this one here, I'll have x plus 5, x plus 4 times x plus 1. That's a difference of squares. In the denominator on the second one, there's no fancy factoring to do, but you can take out a factor of 3 from both. There's a common factor there. So 3 times x plus 5. Now in the second one, or sorry, in the first fraction in the denominator, there's a common factor, which actually I'll write it over here first. You can take out a 2, so it'd be x squared plus 3x minus 4. And then that trinomial in the brackets can be factored further to x plus 4 and x minus 1. Okay, so now that we've factored, let's be smart and write our non-permissible values before we mess everything up with our canceling. So anything that's in the denominator, it cannot be equal to 0. So let's just look one by one at each of those factors and decide which x value would make them 0. So for the first one, x plus 4, negative 4 would make that 0. For the next one, 1 would make that 0. And for the last one there, negative 5. So these are our non-permissible values. Okay, now let's go ahead and cancel out. So anything that's in the numerator and the denominator, any factor can be canceled out. X plus 5 can be canceled with x plus 5. X plus 4 can be canceled with x plus 4. So even if they're in the same fraction, as long as one's in the numerator, one's in the denominator, you can cancel them. X minus 1, x minus 1. I think that's it. So now we're simply left with 1 over 2 times x plus 1 over 3. And so this would just be x plus 1. If there's only one factor left, you can put brackets around it. It's not incorrect, but you can also take off the brackets. That's probably how you'll see it in the answer key. Okay, if you want to try the next question there, you'll have to do the same thing, like factor first, and then do your canceling, but the idea is the same. Okay, that is the end of the lesson.